This lesson will be on covalent bonding. So in the previous lesson you learnt about ionic bonding. If you recall, ionic bonding is a bonding that takes place between metal and non-metal elements. Covalent bonding, on the other hand, occurs only between non-metal elements. Similar to ionic bonding, in covalent bonding, each atom would gain a full outer shell of electrons. So it becomes similar to the electron configuration would become similar to that of a noble gas. When two or more atoms are chemically bonded together, we describe them as molecules. So in ionic bonding, ions are formed, whereas in covalent bonding, molecules are formed, such as this water molecule, H2O, which you see here. So hydrogen, two atoms of hydrogen have covalently bonded to one atom of oxygen, and I'll be explaining what this diagram is all about very shortly. Covalent bonds, such as what you see here, between atoms are very strong, and the combined bonded unit of atoms is what's known as a molecule. So remember, covalent bonds form molecules. The key difference between covalent bonds and ionic bonds is that in covalent bonds, the electrons are shared between atoms. In ionic bonds, the atoms either lose or gain electrons. So if you remember, in ionic bonding, metals are going to lose electrons and non-metals are going to gain electrons. In covalent bonding, all of the atoms that are taking part in covalent bonding, they're non-metal atoms or elements, and they're going to share their electrons. So if you have a look at this example here of two chlorine atoms, chlorine, which is in group 7, has an atomic number of 17, and it's in group 7. It's going to have 7 electrons in its outer shell. In order for it to have a full outer shell, it requires 8 electrons in its outer shell. Therefore, it requires one more. If you have two chlorine atoms, what they can do, such as what you see here, they can overlap their outer shell or their outermost energy level, and by doing so, they're sharing a pair of electrons, or they're forming a single covalent bond. When they do that, each chlorine atom has now gained one more electron in its outer shell. So this chlorine atom here is going to have 8 electrons or full outer shell, and so will this chlorine atom here have a full outer shell. And when they've covalently bonded together, they formed a molecule, a chlorine molecule, Cl2. And that's why chlorine exists naturally as a molecule, because it's two atoms of chlorine that have covalently bonded. A dot and cross diagram is what you'd use to display the covalent bonds between different atoms. So these small covalent molecules, you could represent them using dots and crosses, and it's important that the crosses you use crosses to represent the electrons from one atom, and dots to represent the other electrons that have come from another atom. Okay, and the main ones that you need to know about are hydrogen, chlorine, oxygen, nitrogen, hydrogen chloride, water, ammonia, and methane, but I will show examples of each. Okay, and this here is called a display formula. So if I start with this one first, this is a hydrogen molecule. It's with the formula H2. Hydrogen has got 1 electron in its outer shell. It's only going to have one energy level, and the first energy level of any atom can hold a maximum of 2 electrons. Therefore, hydrogen requires one more electron. So if there's 2 hydrogen atoms, they can overlap their outer energy level, and by doing so, they will now have a shared pair of electrons, and they'll have 2 electrons in their outer shell. So this hydrogen atom here will have 2 electrons in its outer shell, and so will this one, because they're sharing a pair, and they're providing 1 electron each in this example, because this is a single pair. You can also have double pairs and triple pairs, and I'll show you examples of them as well. This line here in the display formula is representing the covalent bond. Ammonia, which has the formula NH3, consists of one nitrogen atom covalently bonded to 3 atoms of hydrogen. Nitrogen is in group 5 of the periodic table, and therefore will have 5 electrons in its outer shell. If it's got 5 electrons in its outer shell, it requires 3 more electrons in order for it to have 8. which would mean it have a full outer shell. Hydrogen have one each. So if these three hydrogen atoms are going to covalently bond, such as what you see here, to the nitrogen atom, and form three single pairs or shared pairs of electrons, now nitrogen would have 8 electrons in its outer shell, and each hydrogen atom would have 2. So the hydrogen atoms will have 2 electrons in its outer shell, meaning it's got a full outer energy level, and so would the nitrogen atom. Okay, these 2 electrons here are called non-bonding electrons because they're not sharing any electrons. These are shared pair of electrons. So in this example of ammonia, there's 3 single shared pair of electrons, 1, 2, and 3. This would be the display formula. So each line is representing each covalent bond. Chlorine, or Cl2. Chlorine is in group 7, so it's got 7 electrons in its outer shell, and therefore requires 1 more electron in order for its outer shell or outer energy level to be complete. Cl2, in this example of Cl2, 2 chlorine atoms are overlapping their outer energy level, and they've gained 1 more electron each in their outer energy level. It's important to bear in mind, neither of the atoms in any case of covalent bonding, none of the atoms are going to transfer electrons. That's not what happens. Instead, they're sharing electrons. So in this example, there's a single shared pair of electron, so it's a single bond, as you see by this one line here. Oxygen, this is slightly different, but it's covalent bonding again. This is a double bond because oxygen is in group 6 of the periodic table and therefore has 6 electrons in its outer shell. As such, it requires 2 more electrons in order for it to be, in order for them to have a complete outer shell. So they're going to overlap their outer energy level and form a double bond, which is 2 shared pair of electrons. 1, 2. So each oxygen atom is going to provide 2 electrons to the other, and that would mean that the oxygen atoms have gained 2 more electrons each, and as such oxygen would have 8 electrons in its outer shell and each, so both of them would now have 8 electrons each in its outer shell, just like a noble gas. These 2 pairs, 1 and 2, are the bonding electrons, and these are the non-bonding electrons here. And that's why there's 2 lines here representing a double bond. Nitrogen. Nitrogen is in group 5 of the periodic table, so it's got 1, 2, 3, 4, 5 electrons in its outer shell. It requires 8 electrons, so it needs 3 more electrons in its outer shell, and it can do that by overlapping its outer shell, outer energy level, and now it's formed a triple bond, so 3 shared pair of electrons, 1, 2, and 3. When it does that, it now has 8 electrons in its outer shell, and it's a triple bond because there's 3 shared pairs. Okay, and each nitrogen atom has got 8 electrons in its outer shell, and these 3 lines are representing the triple bond. Hydrogen chloride. Hydrogen, it has 1 electron, it requires 1 more. And so does chlorine. Chlorine is in group 7, has 7 electrons in its outer shell and requires 1 more in order for it to have 8. So if it forms a covalent bond, this shared pair of electrons means that chlorine now has 8 and hydrogen has 2. Hydrogen only requires 2 because it's got 1 energy level, so it needs 2 electrons, and chlorine needs 1 more in order for it to have 8.